Okay, so let's take a look at graphs of sine, cosine, and tangent functions, right? So in order for us to kind of graph these, you need to know some of your special angles. Specifically, you should try to understand the angles of theta of 0 radians, pi over 2 radians, which is 90 degrees, pi radians, 3 pi over 2 radians, and 2 pi radians. Okay, so try to know those values, guys, really important. And when we're looking at periodic functions, I'm sure you have seen this in prior lessons in your prerequisite courses, but when you're looking at periodic functions, what you need to do is you need to look at the fact that they are repeating. All functions that repeat are periodic, right? So these are functions that repeat. The graphs of y is equal to sine x and y is equal to cosine x are similar in shape. They have the amplitude of 1 and a period of 2 pi. Okay, so I'll explain what each of that means. Before I do that, you can imagine that if you know the points of your graph, you can plot this on grid, right? So for the most part, I'm going to look at the domain where x is between 0 and 2 pi radians. So this is x, 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And what I'm going to look at here is y is equal to sine x, right? So in this case, sine 0 is 0. These are values you should already know. Sine pi over 2 is 1, sine pi is 0, sine 3 pi over 2 is -1, and sine 2 pi is 0, okay? So those are your values, and you can see that being plotted here, right? So this apparently was pi over 2, right? This apparently here is 3 pi over 2, right? This is 2 pi, you can see that. In terms of cosine, if we're looking at the same domain between 0 and 2 pi radians, if we're starting at 0 here, y is equal to cosine x is 1, pi over 2, it's 0, pi, it's -1, 3 pi over 2, it's 0, and then 2 pi, it's 1. Okay, so in that case, you're basically going to get these values shown here. And you can imagine that the curve is slightly different. It doesn't appear identically the same, but overall the shape is the same. Specifically, if you take a look at these values here, right, the minimum value and the maximum values, those are going to be conserved throughout both of these functions. Okay. Also, the halfway point between the minimum and maximum, so this is your maximum, this is your minimum, your halfway point, which is called the horizontal axis, is also the same. Okay, so a few bits of terminology. So your maximum point is the highest point. It's usually demonstrated by a peak. And the maximum point here is +1 for both cases. The minimum point is the lowest point. It's usually demonstrated by a trough, which is kind of like a valley, which is this point here and this point here. In both cases, -1. The horizontal axis is a symmetrical axis that's horizontal, which basically is the halfway point between the maximum and minimum. Another way we can write this, the horizontal axis is the maximum plus the minimum divided by 2, okay? So for the horizontal axis, if you actually plug in those values, you'll actually notice that's 0. And because the horizontal axis is in terms of y, what we can write here is the horizontal axis in the form of y is equal to maximum over minimum plus minimum over 2, excuse me. In both cases, they have a horizontal axis of 0. You can imagine that if you apply transformations to this, it can change the shape of the graph. Another thing that we need to talk about here is this amplitude. What is an amplitude? Well, an amplitude is a vertical displacement from the horizontal axis either to the maximum or to the minimum. In both cases, the horizontal axis is 0. Right? Maybe there's a different color here so you guys can see it. Right? The horizontal axis is 0. To the maximum, it's a distance of 1 unit. To the minimum, it's a distance of -1 unit or just 1 unit down. Right? And the amplitude will always be the same distance from the horizontal axis to the maximum or the minimum. In both cases, there is a magnitude of 1. Okay, so that's something that you want to understand. And essentially, the amplitude can also be calculated using a formula, the amplitude is what we call the maximum vertical displacement. Maximum vertical displacement from the horizontal axis to either the maximum or the minimum. Right, it's the maximum horizontal displacement. Now the amplitude is always a positive value, guys, because we're just looking at magnitude, right? If you're going upwards, it's a positive amplitude. If you're going downwards, it's a negative amplitude. But at the end of the day, the value of the amplitude is always a magnitude, right? Okay, so it's just a positive value, right? So this is basically the amplitude is still 1 here. It's just positive 1 means you're going up 1, negative 1 means you're going down 1, okay? So the amplitude can also be calculated with a formula. The amplitude is equal to the maximum minus the minimum divided by 2. I will show you guys a summary of all of these formulas later on. And another thing that we need to look at here is the period. Okay, we know that a periodic function is cyclic. That's essentially where the name period comes from for periodic. A period basically is a single repeat, right? Periodic means that it's going to constantly repeat, and each repeat is known as a cycle. The period is the length of a cycle. Now, specifically, the period for this cycle, if you take a look at some points, if you start at this point, you can see that it starts to repeat here. If you start at this, well, we can't really indicate here, but if we start at this point, you can see that, it ends up repeating around here. In both cases, this is a 2 pi radian stretch. The period is the length of a cycle in radians. Okay. Now, if you're given angles in degrees, then period is the length of a cycle in degrees, but we're just going to be focusing on radians. Okay. And there's also another terminology. So we're going to use T for period. Right, you can also use P. I think T is more common. You also see this when you study physics and so forth. But T is the period, and there's also something called frequency. Right, we'll call it F. Or usually in math we use K for frequency. Right, the frequency is the number of cycles that occur in a 2 pi radian stretch. Okay, you know that a single revolution is 2 pi radians. However, we know that periodic functions can also be transformed, so the frequency can change, right? But the frequency is the number of cycles that occur in a 2 pi radian stretch. And one thing that you need to understand is that the frequency times the period will always equal 2 pi radians. And so that's something that we will talk about later on, but you can imagine that if frequency is the number of cycles per 2 pi radians, and if you look at the period is basically the length of a cycle, then you should always multiply to 2 pi. Okay, so try to understand it that way. We'll take a look at this more throughout. What I really need you to understand is these values. You need to be able to graph it, guys. This is for sine, this is for cosine. For tangent, let me just make some space here actually, so that I can show you guys what tangent will look like. You can always preview some of these videos later, just if you need the notes. But if you're looking at the points in tangent, we're looking at between x's between 0 and 2 pi radians. Right, this is y is equal to tan x, and you can imagine how this graph gets created. Start at 0 radians, pi over 4 radians, pi over 2, 3 pi over 4 pi. The reason I have to do 3 pi over 4 is because this is undefined. Right, you know that tan pi over 2 doesn't exist. Tan 90 doesn't exist because tan theta is sine theta over cosine theta. And if you plug in tan pi over 2, guys, you're going to get cosine pi over 2, which won't exist. So the denominator would become 0. Right, tan 0 is 0, tan pi over 4 is 1. Right, tan 3 pi over 4 is negative 1, tan pi is 0. right? So this, you're going to get a combination of these values, and essentially what's going to happen is you're going to get something like this, right? So anything that has anything that's 1 essentially will basically be pi over 4, right, and so forth. And you can imagine that there is a vertical asymptote. Let's write here. There's a vertical asymptote that occurs at pi over 2 radians. And so that's what I want you to get from that. Okay, so try to graph this out, guys. See it. The zeros, which are the x-intercepts, are specifically pi, 2 pi, and 0. So if you want a general statement to look at the x-intercepts, it's just n pi, and n can belong to the set of all real numbers. Well, all whole numbers, really. Right? All whole numbers, because if you had n is equal to 0, then it would be 0 radians. If n is equal to 1, it would be pi radians. If n was equal to 2, it would be 2 pi radians. In that sense, they would all be 0. Okay. So try to understand that, but we'll take a look at some examples. So when you're looking at these graphs, what you need to understand here is that you can write the function, the trig function, in this template. All right, f of x is equal to a sine k x plus c plus d. Okay, and you can use different letters, guys. I'm just going to stick with these letters. The value a represents the amplitude. Value k represents the frequency. And this is when you're assessing the graph of its behavior. Okay, so this is purely just behavior. We can also use this template for transformations, and I'll show you guys that later on. K is the frequency, C is the horizontal shift. Okay, and you can write, usually I write horizontal shift as x minus h, right? So let's write this as minus h, but I think if you write it as x plus c, you can see it better. Let's write this as x minus h, actually. Okay, so I'm going to use negative h for this instead. It means the same thing, though. And d here is the vertical shift. Now, in terms of behavior, this d value actually represents the horizontal axis. Okay, so the d value is the horizontal axis, guys. Based on this template, we can actually find our general behavior of the graph. I'm going to show you this via an example. Oh, sorry, guys. Let me just switch back. Okay, so I'll show you this via an example so you can appreciate this, but I'm sure you've done this previously in previous grades, well, in the prerequisite course. So let's say you had 3 sine 2x minus pi plus 4. We want to look at some of the behaviors of this function. Okay. Some of the behaviors, if you look at this template here, a here is 3, so that tells us that our amplitude is 3. Okay, amplitude is 3. We can also see that our c value is 4. Right, so the c value tells us that the horizontal axis is y is equal to 4. We can also find out that our frequency here, our frequency, which is k, is equal to 2, right? So it's this value here, that's our frequency. Before you actually do anything, guys, I would really tell you to factor this out. Right, you can write this as 3 sine 2x minus pi over 2. You can see your frequency a lot better that way. You can also see that your phase shift isn't actually pi, it's pi over 2 radians. Okay? It's pi over 2 radians to the right. We'll take a look at transformations as we kind of continue through this, but this is really important because now you know what your frequency is, and it can also, as a result, determine your period. Now, according to that equation that we talked about, and I've written down all of the equations that you guys need here, so make sure you know all of this. Okay, so try to know maximum, amplitude, minimum point, the d value, which is your horizontal axes, right? Maximum plus minimum divided by 2. It's basically the same thing here, right? Just refer to the letters here. But essentially, if you know your frequency, you can find your period, because we know that the frequency times the period is 2 pi radians. So the period is 2 pi radians over the frequency, which is 2 pi radians over 2, right? And this means there's 2 cycles per 2 pi radians. So there's 2 cycles per 2 pi radians. Each cycle should be pi radians, right? So hopefully that makes sense. So this is telling us a little bit of information, right? It tells us that each cycle occurs in a pi radian stretch. And we also can tell that our horizontal axis is 4. By knowing our horizontal axis and by knowing our amplitude, we can find out that our maximum point should be the horizontal axis plus the amplitude, right? If you had a horizontal axis that was here, to find the maximum, which is here, you're adding the amplitude. Make sense, guys? That's where the formula comes from, or you can rearrange the formulas that I gave you. The minimum point is from the horizontal axis, which is in red, to the lowest point, you're subtracting the amplitude. The amplitude's distance is going to be the same between the minimum and the maximum point. It's kind of like the halfway point. So the minimum point is the horizontal axis minus the amplitude. And if you were to calculate this, you'd have 4 minus 3, which is 1. 4 plus 3, which is 7. And the minimum point here should be 4 minus 3, which is 1. So that gives us a bit of information, right? It tells us that our maximum point is y is equal to 7, our minimum point is 1, and specifically our amplitude here is 3 and our horizontal axis is 4, and there's a repeat every pi radians. Okay, so this is something that's really important, guys. Try to understand it. That's just information, but you can use this notion to graph out your graphs. Okay, so I just wanted you to gauge some of the behaviors associated with that. Specifically, what is the amplitude? What is the frequency? What is the horizontal axis? What is the maximum minimum point? So those are things that you need to understand. You can use this template, or what you could do is you could do a sine k x minus h plus d. For the most part, I'll be using this, guys. I think because this is something that you're already familiar with. So I might as well be using these, but it means the same thing. It just kind of correlate the letters with each other. Okay. So this is where I want to show you some questions on how to look at transformations. But the key ideas are going to be these type of questions, where we actually take graphs and we generate a cosine or a sine function. Okay, so I think you guys can take a look at the behaviors, but I want to take a look at question 19 really quickly. In question 19, we want to create the graph cosine function. I think this will really help you to illustrate why these are so useful. When you're thinking about the graph of cosine function, you want to write this as a cosine k x minus h plus c, right? And essentially, you want to figure out what each of these values means. The amplitude, what is the frequency, what is the period, what is the horizontal axis. You can also find your phase shift. Phase shift is just a horizontal shift. You can call it phase shift as well in trig cases. Okay, but let's say we wanted to look at these things. Okay. So if we're looking at these things, let's take a look at the amplitude first. Before we can take a look at the amplitude, guys, what you need to look at first is what is your maximum and minimum point? Well, our maximum here, if you look at this graph, it looks like 5, right? Our minimum here, it looks like 1. Based on this, we understand that our amplitude is maximum minus the minimum divided by 2, which is 5 times 5 minus 1 over 2, which is 2. The frequency here is, after you find the amplitude, you can also use this information to find your horizontal axis. The horizontal axis is the halfway point between the maximum and the minimum. Technically, that's 5 plus 1 over 2, which is 6 over 2, which is 3. What does that mean? Well, the horizontal axis should divide the maximum minimum in half, and really the horizontal axis is here, right? So at y is equal to 3, you should see a horizontal axis. The distance from the horizontal axis to the maximum, the distance from the horizontal axis to the minimum should be the same. You can actually see that it's 2. That's essentially what we calculated here, right? The amplitude. And now you can start to see how this works. The amplitude is always positive, guys. If you say positive amplitude, you're going up to the maximum. If you say negative amplitude, you're going down to the minimum. The other thing that we need to look at is the frequency. Now, in order to find frequency, you need to find the period, guys. If you're finding the period, you need to find 2 points and see where they repeat. If I started here, you know that it can repeat here. A repeat has to, by definition, has to go from a minimum to a maximum back to a minimum, or a maximum to a minimum back to a maximum. So you can have a single repeat here. Right, what is this distance in terms of our axes here? Well, if the pi is divided by 3 segments, this is pi over 3. This would be 2 pi over 3. So this period here, the length would be here, is 2 pi over 3. And it doesn't matter where you start. You just have to look for a single repeat. Like you could start here. You can see that it repeats here. Once again, this is from pi to, I think that's over there, sorry. Maximum, minimum, maximum. So it goes pi. It should have been over there. 1 second, 0, 2 pi. Yeah, sorry. This goes pi, then 4 pi over 3, then 5 pi over 3. So you can still notice here that this is 2 pi over 3. So the period here is still 2 pi over 3 radians. What that's telling you is that every 2 pi over 3 radians, it does a repeat. From that information, we also need to find the frequency. We know that k times t is equal to 2 pi radians. We also can understand that k times 2 pi over 3 should be equal to 2 pi radians. And as a result, k should be 2 pi divided by 2 pi over 3. And if you calculate this, right, you're multiplying the reciprocal, it should be 3. What does that 3 tell us? That tells us that there's 3 cycles in every 2 pi radian stretch. Okay, so your k value should actually be 3, guys. So now we've actually figured out our a value, we figured out our k value, we figured out our c value. This is what your equation looks like so far. 2 cosine k here is 3, x minus h, plus the c value here we calculated was 3, which is your horizontal axis. And the last thing you need to do here is find your h value. It's called your horizontal shift, also known as your phase shift. All right, you can call it horizontal shift if you want. In order to find this value, you're just missing one piece. All you have to do is plug in a point in your equation. I think the easiest point that I can plug in is this point here. It's the y-intercept, 0 and 1. If I plug in f of 0 here, you get 2 cosine 3, 0 minus h plus 3 should be equal to 1. So then you get 2 cosine, if you multiply this out, you get negative 3h, right? If you multiply this out on the inside, make sure you put brackets, guys. Plus 3 is 1. I'm going to move the 3 to the other side. You get 2 cosine negative 3h is equal to negative 2. If you divide by 2 to both sides, cosine negative 3h is equal to negative 1. If you want to solve for h, what you can do here is you could do the cosine inverse of both sides to get rid of the cosine. If you do the cosine inverse of cosine negative 3h, this and this cancel out. You also have to do the same thing for the other side. You're doing cosine inverse of negative 1. Cosine inverse of negative 1 is your special angle. It's pi. So what you're going to get here is negative 3h is equal to pi. H is equal to negative pi over 3. If h is negative pi over 3, guys, then your equation should look like this. You have all the other pieces. So you have amplitude, which is 2. Cosine 3 x minus h. In this case, the h value is now minus pi over 3, so positive pi over 3 plus 3. That's your equation. Why is this useful? Well, you can plug in points. You can find different values of x, plug it in, and find their equivalent y values. So it becomes really relevant in your description for this function. Really useful to have this, right? And now they're also asking us what is the maximum value and what's the minimum value? Well, we are given that actually from the graph itself. The maximum was 5, the minimum was 1, and if you weren't given the graph but you were given the equation, you can actually see that in this equation. The maximum is your horizontal axis c plus the amplitude, which is 3 plus 2. Your minimum value is your horizontal axis minus the amplitude, which is basically 3 minus 2. Okay, so that's how you can see that from the equation. In part B, they're asking us what is the amplitude. Well, we calculated it, but we basically observed that from our graph. So the amplitude here was 1. Sorry, was 2, not 1. And it was the distance from the horizontal axis to the maximum, or the distance from the horizontal axis to the minimum. And that value should be conserved. It is a magnitude after all, right? The amplitude is always positive. However, a negative amplitude means you're going down. A positive amplitude means you're going up, okay? What is the vertical translation? Well, the vertical translation here is the same as the horizontal axes. You got to think about this in terms of transformations, right? It's 3 units up. Okay, so hopefully, yeah, you're not a stranger to transformations. We will look at transformations also. However, it's not anything new. It's something that you should already kind of be familiar with. What is the period? Well, the period here, we know it's 2 pi over 3 radians, because that's the length of each cycle. And what you can do is you can just determine that by picking 2 points on the graph and finding the distance between them. It should repeat constantly, hence why it's called a periodic function. And in this case, what was the value of k? That was the frequency. We calculated that as 3. That's telling you that there's 3 cycles in a 2 pi radian stretch. And the last thing we did here was we calculated the phase shift, which stated that the phase shift is pi over 3 units to the left. Okay, so you can get a lot of information from these graphs, guys. You need to be able to formulate an equation. These equations are really useful. So it's something that you want to kind of practice and really just get the hang of, because it's really useful in not only just in graphs but also in applications. Sorry. So what I want you guys to do, and what we will do later on, is we will take a look at some of these application questions. But before that, what I really want you to do is really understand this general template. Right, and the values mean really the same thing for both graphs. It's just you're just having 2 different functions. I want you to understand what each of these values means. And try to answer these questions, and we'll do a sample question for an application. Does that make sense? So let's take a look at question 18. And in the question is saying that a popular attraction in many water theme parks is the wave pool. Suppose that the wave generator moves back and forth 20 complete cycles every minute. Right, so we have 20 cycles every minute. And it produces waves measuring 1.2 meters from the top of the crest to the bottom of the trough. Okay, so you can imagine that if you're looking at the waves, think of it like that, right? It's going to be sinusoidal. It's going to keep repeating, right? And basically, it goes. Sorry, should have repeated this way. Right, so it's saying that the wave generator moves back and forth 20 complete cycles every minute to produce waves measuring 1.2 meters from the top of the crest to the bottom of the trough. So this distance here is 1.2 meters, okay? You want to model the displacement d in meters of the wave from the mean pool level as a function of time in seconds. Okay, so let's think about what this would look like, okay? And this is very important because when you're looking at this, you can model this either as a cosine or a sine function. However, something that you want to understand, actually, and it'll save you a lot of time because you don't have to solve for your h value. We know that sine functions start at 0, right? Because you can imagine that pi over 2 here, this should be a sinusoidal curve. Sorry, guys, it's a little messy here. Maybe I should use a smaller pen so it's just easier to draw. Right, but if you are looking at a sinusoidal curve, you can imagine that the sine function looks like that, where, you know, this, if you're looking from 0 to 2 pi radians, this would be pi and this would be 2 pi, just based on the values that we know. Sorry, this would be 2 pi, just based on the values that we know for sine, right, for the special angles. The maximum value would occur at 1. Right, the minimum value occurs at 3 pi over 2, which is -1. And that's basically your sine graph. Whenever you're looking at a scenario that's starting at 0, you would try to model this as a sine function. If it starts at 0 and then enters its maximum, this is a positive sine function. If it goes from 0 and goes to its minimum point at -1, then this would basically be a negative sine function. Okay, try to know those templates, right? So you can imagine that if you're looking at modeling a scenario using sine, if it starts at 0 and then goes to the maximum, you're going to use positive sine. If you're looking at modeling a scenario that starts at 0 but then goes to its minimum first, then you should use negative sine. Likewise, for cosine, cosine doesn't start at 0, right? Because cosine 0 is 1. The graph does this. Right, so at this point, this is pi over 2 radians. Right, this is basically pi radians. This is -1, and this is basically 3 pi over. This is 3 pi over 2 radians, and this is 2 pi radians. My take home here is that positive cosine starts at 1, negative cosine starts at -1. Okay, so if you're modeling a scenario where you're starting at the very bottom of something, I would use negative cosine. And for the most part, we're going to be mainly using negative cosine because you don't really start at the top of something that's moving periodically or cyclically. You usually start at the very bottom, right? So if you're looking at anything that starts at the bottom, you're modeling it with negative cosine. Anything that starts at the top, you're modeling it with positive cosine. Right? It depends on the scenario. Now, if we consider this scenario, I just wanted you guys to think about that, but if we consider this scenario, we're basically starting at the horizontal axis. Whenever you start at the horizontal axis, which is basically indicated by sine, whenever you start at the horizontal axis, guys, you always use the sine ratio. Okay, so you use the sine for modeling these periodic functions when you start at a midpoint, or basically start at the horizontal axis. Use cosine to model scenarios if you start either at the minimum or the maximum point. Right, and that point, that's based on which value you use, right? This starts at the minimum, right? We should say maximum or minimum. At this point, this function starts at the maximum. This function starts at the minimum. Okay, so it really depends on what you're given in terms of the information. Let's take a look at this scenario. So in this scenario, we're going to start from the very baseline. So the very baseline is basically the horizontal axis, right? This is when, you know, there is no high tide or low tide, or there's no high waves or low waves, right? So because of that, I'm going to model this using sine x. And because I'm modeling this using sine x, you have to use the template a sine k x minus h plus c. Yeah, this is the template I'm using. Now, there's something important to understand, that it doesn't matter which sine or cosine function you use. It doesn't matter which ratio you use. At the end of the day, they all mean the same thing. It's just it'll make using one over another will make it easier for you. Right? If you use the appropriate sine or cosine, if you use the appropriate periodic function, your calculations are a lot more streamlined. However, they'll both mean the same thing. Okay. So either way, you have all of these you have four options really: positive sine, positive cosine, negative cosine. Technically, you can use either or. It doesn't matter which one you use, except if you don't use the right, if you don't use the most appropriate case, you're going to have to do a lot more calculations. Okay, you'll see that when we do more questions. So let's take a look at the scenario. The scenario is telling us that our frequency, it's telling us that there's 20 cycles every minute. That's our frequency. Well, you want to write this in terms of, let's think about writing this in terms of how long does it take for one cycle? If there's 20 cycles in 1 minute, which is 60 seconds, then we know that there is one cycle in 3 seconds. How did I come up with that? Well, I just scaled the ratio down by dividing by 20. At the end of the day, most things are just ratios. So the period here is 3 seconds. But hold on a sec. We said that the period was supposed to be as written as an angle, right? So in this scenario, you are using angles, but you're kind of cross-comparing it to an actual another unit. You can understand here that if I let t represent time in seconds, you're going to kind of, when you're putting it into this equation, you're creating an angle variant to that. You're basically standardizing all of your angles as time, okay? If you let t represent time in seconds, I'm going to let, we'll call this d of t, represent the displacement. Now, I always want to see let statements, guys. Let d of t represent displacement in meters after t seconds. And their baseline here is from the mean pool level. The mean pool level is basically when the pool is just at 0, right? And then when you have waves, the water level rises. When the water level falls, you get a trough, right? But this is the mean pool level, and that's the horizontal axis. Okay, so usually a baseline, a line of 0, some average line is your horizontal axis. And you'll understand this more when you keep doing questions. It's just different scenarios for each, guys. But the key idea about this is we're going to model this equation in terms of sine, okay? Except this time instead of using y, we're using d of t is equal to a sine k t minus h plus c. So I'm just using this instead of x, right? And I need to find some of these parameters. Now, I've mentioned before that basically we're starting at the horizontal axis. We're not given the information whether it's if the graph is reaching the maximum wave height or the minimum wave height first, but we can just kind of leave that to our own devices. So in this scenario, if we know that the distance between the highest point of the wave and the lowest point of the wave is 1.2 meters. As a result, this distance here, right, this distance here, let's show you the different color. This distance here from the horizontal axis, which is in red, the halfway point, to the maximum minimum, what we stated was 0.6 meters. It should be halfway, right? The total length is 1.2, so the maximum point occurs at 0.6 meters above the mean pool level, which is set at 0. This is your mean pool level. And your lowest point occurs at negative 0.6 meters. That's below your mean pool level. Okay, so think about it like that. Try to draw this out, guys. Having said that, just by generating this graph, we can actually determine that our maximum here is positive 0.6 meters. Our minimum here is negative 0.6 meters. And our amplitude, because our horizontal axis is y is equal to 0, that's our mean pool level. Our horizontal axis, C, is just basically 0. Now that you have a maximum minimum, just from the graph, you can tell that your amplitude is 0.6 meters. But if you wanted to calculate it, you can just do maximum minus minimum divided by 2, which is 0.6 minus negative 0.6 divided by 2, which is 1.2 divided by 2, which is 0.6. Also, if you know your maximum and minimum conditions, you can also find your horizontal axis if you didn't already figure that out. You have maximum plus minimum divided by 2, which is 0.6 plus negative 0.6 over 2, which is 0. Okay, so you can actually use these equations as well to kind of help you to calculate these values. And another value that we calculated was the period, right? Now, in this scenario, because we have our frequency, and our frequency here is 20 cycles per 60 seconds, our period was 3 seconds. If our period is 3 seconds, if you think about KT is equal to 2 pi radians, you want to try to create the frequency in terms of angle measurements. Once we know our period, which is 3 seconds, K times 3 is 2 pi, then the frequency should be 2 pi over 3 radians. If you convert time into radians, this is your conversion factor. It basically tells you that every 2 pi over 3, there's this many cycles, right? There's this many cycles per 2 pi stretch. Okay, so the period, the frequency is what you need to actually calculate out. Everything else is there. So now that you look at the equation here, your function looks like a, which was 0.6, sine k is 2 pi over 3, t. Now, because we use the appropriate function for this, your h value is 0. If you use the right function to model it, if you use the sine or the cosine function to model it, if you use the right one based on the scenario, then your h value is 0. So we actually don't need to look at our h value. That's one of the benefits of using the right function. It depends on if the graph starts at the horizontal axis, if it starts at the maximum, or if it starts at the minimum. If it starts at the horizontal axis, you can use either positive or negative sign unless they tell you otherwise. But if it starts at the minimum, you have to use y is equal to negative cosine x to model it. So you would model your function as negative a cosine k x minus h plus c. If it starts at the maximum point, you should be modeling your function as positive a cosine k x minus h plus c. Okay, so that's really the difference, right? There's really 3 conditions. If it starts at the horizontal axis, you can use sine to model the function, to model the equation. If you're starting at the maximum point, you have to use positive cosine. If you're starting at the minimum point, you're using negative cosine. So just try to understand that, guys. I think it'll become more evident when you do more questions. And in this case, if you use the right function, your phase shift, h, horizontal shift, is 0, plus your c value. In this case, the c value we already calculated was 0. So this is the equation of your scenario. And based on this equation, you can, by finding t in seconds, because I let the variable represent t in seconds. I think the let statement's here, right? The t values in seconds. If you have a certain number of seconds of time that's passed, you can figure out the displacement of the graph. Having put this a specific way, let's say we're looking at this after 2 minutes, which is 120 seconds. So you're doing d of 120, which is 0.6 sine 2 pi over 3 times 120. And if you multiply this out, I'm just going to simplify this first. This is 40, so this is 80 pi. So d of 120 is 0.6 sine 80 pi. Sorry, it should be 80 pi here. And if you punch this in your calculator, guys, this goes back to 0. So this tells you that after 2 minutes, we're going back to 0 meters. Well, that makes sense because it's telling us here that every minute there's going to be 20 cycles. So in 2 minutes, there's going to be 40 cycles. And because you started at 0, right? Well, it should have been started at 0. So because we started at 0, I think I showed it here. Because we started at 0, then you should end off at 0 after a cycle. Okay, so these equations are really useful, guys. Try to really understand how to make one, just based on the information you're given. Okay, so let's take a look at another question. This is question number 17. It's on slide 5. In this scenario, the octopus ride at an amusement park completes 1 revolution every 60 seconds. Okay, so that already tells us a bit of information. That you have 1 cycle. Revolution is a cycle, guys. 1 cycle every 60 seconds. The cars reach a maximum of 4 meters above the ground and a minimum of 1 meter above the ground. Okay, so you can think about this as kind of like a Ferris wheel, right? These Ferris wheel questions will be really important, right? So think about basically the distance off the ground that this Ferris wheel is, or this amusement park ride is. It's always 1 meter above the ground. Okay, the minimum height is 1 meter above the ground. The maximum height is 4 meters above the ground. You need to draw an image out for this. Okay, and this won't change, right? So think about this as some kind of amusement park ride or Ferris wheel. You can draw it like this, right? Even if the ride is going like that, right? I know you guys have probably went to Wonderland, so you know what I'm talking about, right? I thought it would be easier if I just drew it 2-dimensional like this, right? But it means the same thing, guys. The highest point here would be 4, right? However you guys want to draw it, go for it. It doesn't matter. It's the same thing, right? But the key idea of this is that we want to look at creating a function that models height in meters. Height. So I'm going to let h of t represent height in meters after t seconds off the ground. So you're creating a function where you're looking at how high is each cart on the Ferris wheel after t seconds off the ground. So you can imagine that these are carts, right? So I'm going to say that this is like the lowest cart. Right, so we're just putting it in perspective of the carts, and you can imagine that because the carts are rotating, right, they'll eventually reach the same position, right? It's periodic, so it repeats. We're given a bit of information here. We're given that the minimum point here is 1 meter. We're given that the maximum point here is 4 meters. So this tells us also that we have a cycle every 60 seconds. So the period is 60 seconds. Right? And we're doing the independent variable as t seconds. The first question is asking us, okay, what is the amplitude of this function? Right? You can imagine that whatever function we use, if we use positive or negative sine x, positive cosine x, or negative cosine x to model this function, they will have the same parameters of amplitude, frequency, right? The period will still be the same, right? The horizontal axis will still be the same. The phase shift may differ, but these 4 parameters will stay the same. So you can calculate these first and then figure out what function am I using, right? So let's find the amplitude here. The amplitude is the maximum minus the minimum divided by 2, which is 4 minus 1 divided by 2, which is 3 over 2, right? We also know that our horizontal axis, which we've labeled C, is the maximum plus the minimum divided by 2, which is basically 4 plus 1 divided by 2, which is 5 over 2. We also have the period, which tells us that the frequency, k times t, which is frequency times period, is k times 60, which is equal to 2 pi radians, right? As a result, k is equal to 2 pi over 60 seconds. So this gives you an equivalent expression in terms of radians. You're normalizing the data from seconds into radians. So now k is equal to pi over 30 radians. So now you have these 4 bits of information. After having these 4 bits of information, you want to ask yourself, okay, which function am I going to be using to model the scenario? You can imagine that at time 0, if you're boarding a Ferris wheel, you're not boarding it from the top, you're boarding it from the bottom, right? If you're boarding it from the bottom, then that would tell you that the best function that I can use at time 0, you should be at the minimum point. So I would tend to use cosine x because at time 0, you are at the minimum. And the minimum basically means the minimum height, right? So at time 0, you should be 1 meter off the ground. So h of 0 should give you 1 meter, right? Because the Ferris wheel is 1 meter off the ground like we've indicated. Okay, and now you understand that, because you made a decision on what function to use, right? You want to model your equation now. H of t is negative a cosine k t minus h plus c. If you use the right equation, guys, because we're using a cosine function and the graph starts at the bottom, our h value is 0, right? Now, in the case that you don't know that directly, you can always plug in values to test for that, but you'll find that h will be equal to 0. This is really the template that you're going to be using, and this makes your job a lot easier because now you don't have to worry about defining the h value. You can just do substitution, right? Now, based on this, because you have this equation, we know the parameters. We know what a, k, c is. We just have to plug it in. So h of t here, we said a was negative 3 over 2 cosine. K here, well, we said k was pi over 30 t. And c, which was the horizontal axis, we said it was 5 over 2. This is the equation for our graph, right? And based on this, we can find out the position of the points of the carts after t seconds, right? And I've started with the lowest cart. So at times t is equal to 0 seconds, the lowest cart was 1 meter off the ground. That's the cart you're boarding. And as they're moving, right, all the carts will feel the same position over time, right? They'll all cycle through the different heights of each position on the wheel. Okay, so it's really important that you understand it. And another thing that you can also understand, the minimum point was 1 meter. The maximum point was 4 meters. This halfway point where the axle is, this is the radius, and the radius is actually the amplitude, right? The amplitude was 3 over 2, which is 1.1.5. You can actually notice that it's the halfway point between the highest point and the lowest point, right? And this is your horizontal axis. Your horizontal axis here was 5 over 2 meters, which is 2.5, right? It's the midpoint. Try to draw the image out, guys. You'll see it, right? Really think about what it means. But that's your equation, right? And we also determined our period. Well, we had our period, but we also determined our frequency by finding the period. So after you find the equation, you can find certain values. Like for instance, if I wanted to determine the height after, let's do 30 seconds. If you want to determine the height after 30 seconds, you just let t equal 30. You plug that in. You do h of 30 is equal to negative 3 over 2 cosine pi over 30 times 30 plus 5 over 2. And you can see that 30s cancel out, and you're left with negative 3 over 2 cosine pi plus 5 over 2. And cosine pi here we know is negative 1. So this is positive 3 over 2. Sorry, because negative 1 times negative 3 over 2 here is positive 3 over 2 plus 5 over 2. And the difference here is basically 7 over 2, which is 3.5 meters, right? So it's really close to the peak here, which is 4 meters, right? And you should not see a value that exceeds the 4 meters because then that means you're doing it wrong. The range of this height here should be between, h of t should be between 1 meter and 4 meters. Okay, so think about that in terms of your drawings, guys. Okay, so that's essentially how you create the equation, right? So think about how you can use that, but also you can use this equation to find the time it takes to get to a particular height. For instance, if I let h of t get to 4 meters, which is the maximum height, If I want to figure out the time it takes to get to the maximum height, then what you do is you plug this into your equation. Right, so I would just plug this into my equation. Then I would just move the variables around and isolate for t. So you get negative 3 over 2 cosine pi over 30 t is equal to 4, which is basically 8 over 2 minus 5 over 2. Then you get negative 3 over 2 cosine pi over 30 t is equal to 3 over 2. You divide by 3 over 2 to both sides. You basically get negative cosine pi over 30 t is equal to 1. So as a result, cosine pi over 30 t is equal to negative 1. And if you do the cosine inverse, pi over 30 t is equal to pi. T is equal to pi times 30 over pi, because you're dividing by pi over 3, right? Pi over 30, sorry. And you can get t is equal to 30 seconds, which would make sense because we know that a cycle takes a minute, which is 60 seconds, so half a cycle. You should be at the halfway point, right? You should be at this point. Oh, sorry, guys. You should be at basically this point at 30 seconds. So it's a really useful tool. Try to understand it, guys. Okay. And we'll do some more questions just to kind of get this point across.